So let's start with today's class. That was the doubt. And what do we have in today's class? Okay, this is a pretty practical example. Means it can help you somewhere or the others. We are going to do the factorized form. I'm going to go even more easier. Yeah, somehow I think the last two classes, I try to pull you up a little faster. A lot of tough things happen. So I'll keep it short and sweet, right? To the point. We'll see what is a factorized form. Using the factorized form, we will see how to identify natural numbers, odd, even, squares, cubes. You would have read this, right? Ending with zeros is a nice theme of questions. How many zeros at the end? Okay. Multiples, factors are continuously going to come. Yeah, you need multiple factors are a very important thing in maths again, right? If A is a multiple of B, B is a factor. In fact, we'll go ahead and find the number of factors. Common factors of two numbers. This is decently confusing. Okay, so you will have some two very nice tricky questions. If you miss out over that, you have failed the test. Yeah, and this I don't think so we'll be able to continue today. So no answers for this. So give it a little more thought, students. I'll answer all of them. Yeah, that's fine. We can answer even in the group. You can keep asking. But till then, if you don't do it, there's no point in me telling you. Yeah? So let's start, students. Factorized form. Now the textbook definition is very easy, students. To prime raised to a, break the number into primes. Okay, break the number into primes and collect all like primes together. What is this collect all like primes? Collect means all P1s you collect them and you write them as P1 raised to A. So for example, if I have a number 720, right? You could, in the first step, there are many ways you could break it. I don't know how you're going to break it. But I would typically use that end 0 is helping me. Then rather than 2 and 36, I'll use bigger numbers. Okay, 8 into 9 into 10. Now it is still not primes, right? So you would break it into prime. Now this, again, to save time, I'll write it together. This is 3 raised to square. And this 10 is not prime, so I write it 2 into 5. So now have I got all the primes, 2, 3, 2, 5? So is this a factorized form? This is one error that I'm highlighting. Yeah, you should know where errors happen. Is this a factorized form? Sab to prime hai, 2, 3, 2, 5, everything is a prime. Yeah. So the problem is you cannot have the 2 at two different places. You have to collect them together. Okay, so this is going to become 2 raised to 4. The 2's are collected. That is what I meant by collect together into 3 square into 5. And that 5 is nothing but 5 raised to 1. 1 we don't write. So this is the factorized one. So two checks only. Remember P1, P2, P3, P4, all of these have to be primes. Yeah. Error number 2, which is going to happen. A lot of us are going to make this mistake. This is not a prime factorized form. Right? Why? Because this is not prime. So there are only 2 errors that happen. And they happen with the best of the people. It's just in the haste. This is not a prime. The second error is this. Collect the 2's together. If you don't, you are going to get a wrong answer, which we'll see in a moment. Yeah, if I recall. Then that is your prime factorized form. So they are primes, and if I want to add a word here, they are distinct primes. Distinct means alag alag. No 2 of them can be same. Oh, check. Now this question suddenly catches a lot of people by surprise. So it's a very silly question kind of a thing. How many values of A for how many values of A is the number? Now this is some number. This number should be a natural number. So what is the value of A? Yeah. So for example, I'm just giving you an example. So if you notice this now, and I'm telling you, even the best of the student gets suddenly zapped by this. So what am I supposed to do? And that is the fun bit of factorized form. When you get stuck, when you don't know what you have to do, how do you handle? You break it up into factorized form. Most probably the way forward will be no. So we'll do that later, but first let's understand the question. Many times people don't even understand. So for example, if I take A is equal to 5, just now this is guess. This is randomly chosen to explain for those who do not understand. If A is 5, tell me what will this become? 15 raised to 8. Okay, 28 raised to 3. And tell me what is this? 35. Now, is this a natural number? Is it natural? That's the question. So the question is, what value? Yes, no, someone can guess something like right now. So if I ask you, is 17 by 35 natural? And I'm pretty sure you're going to argue, nah? Doesn't look this, right? But then what you see is, so this 35, natural numbers don't have denominators. But then do you see this 35 and something happening over here? So what happens? The 35 is nothing but 7 into 5. And that 5 can cancel with this. This 5 will cancel out with this. Now something will happen. I'm not doing the whole thing. And will this 7 also cancel out with this 28? So what will you get? A number which has only 1 in the denominator, and that is a natural number. Right? So to cut a long story short again, so I gave you the meaning of the question. So I took A as 5. So it is saying you took it as 5. You could take it as 6. You could take it as 7. But what happens if I take A is equal to, let's say, 10? Randomly again I'm putting. So can you guess something what's going to happen to A at 10? 10 plus 3, 13. So doesn't seem to be a problem. 28 raised to 8 minus 10 is a minus 2. Okay. And this is going to become 35 raised to 20 minus 9, 11. So now what is the problem going to happen somewhere? Think about it. Do you
Denominator will not get cancelled.
The denominator will not get cancelled. And why? Because now it is not just a 5 and a 7. It is a 5 raised to 11 and a 7 raised to 11. Now the 5 raised to 11 can probably cancel from something from here. Why? Because this is a 5 raised to, I can see a 5 raised to 13. So the 11 will cancel out from here. But do you think the 7 is going to cancel from here? Forget about it cancelling. From there, the 7 will come in the denominator. This, if you write it, this number is nothing but 7 raised to minus 2. And something more will be there. And what do you do with this 7? What is the meaning of this? This will come in the denominator. So if it's in the denominator, it's not going to be a natural number, right? So those are the ideas. So how do you handle it? There's another question for you to try out. So I'll just be very swift. You factorize it. And now your challenge is how fast can you factorize it? 3 into 5. Do you see a 3 here? No. Do you see a 3 here? No. So I'm writing it in one go to save time. Okay. A plus 3. 3 ka powers ho gaya. Then I see a 5. Okay. And think now don't copy me. Please do the pencil work yourself. I've given you the path. 5. There's a 5 here also. So when the denominator goes to the numerator, the index will become negative. Okay, so I'm writing it in one go. You can confirm whether it's correct or not. Keep your pencil, pen, everything handy. This is 5 raised to this. This will go at the minus a. So I can see, observe how do I write. Either a minus 2a is a minus a. 3 plus 9 is a 12, if I'm not wrong. Let me confirm it. I guess it should be 3, 5. Then I see this is taken care of. 5 is taken care of. Oh, there's a 2. There's a 4. Okay, let's handle the 7 first. 7 is here, 7 is here. This is 8 minus a, the same business. Oh, so this is a minus 3a. Okay, and 8 plus 9, 17 minus 3. Only a 7 is handled. Is there a 4 also? Now, if you write a 4 raised to 8 minus 8, this is an error. You will make a mistake. So what is a factorized form? A factorized form has to be prime. So please be a little careful. So this has to be 2 raised to 16 minus 2a. Last bit. So you wrote the factorized form. Now, can you tell me when is a factorized form a natural number? When will this be a natural number? So in the last slide, we focused on P1, P2, P3. Right? Now I am focusing on this A, B, C. What values can A, B, C take such that it is a factorized form? And we saw a hint just now. What we saw a hint, you cannot have negatives because then they will go in the denominator. That's all that you have to do. So now the link will become A plus 3. This number could be 3 is a prime, na? Prime. So it could be present or absent. And if it is present, it could be once, twice, 3 times. So absent means it could be 0. So this could be 0 or 1 or 2 or 3 or so on. So how do you write this? You write this as A has A plus 3, or let me write it from the left. So A plus 3 could be 0 or 1 or 2. It cannot be decimals also. Okay, so what will A become? The 3 will go to the minus side, or algebraically you will write is greater than equal to 0. A is greater than minus 3. So let's write everywhere all the things here. If this 12 minus A is greater than 0, or so can you do it on orally like this? And think logically, na, A cannot be more than 12. If it is 12, it will become 0. If it's 13, it will become. So it cannot be more than. It has become a less than. More than, less than, again, some things that, you should think logically. Oh, this is a minus. Oh, to isko upper limit hai. It cannot go beyond something. Naito it will become a problem area. So what is it less than? 3 5s are 15. Okay. 3 6 are 18. It can't be more than 18. So has to be less than equal to 5. Oh, this is also a minus sign. So what does it saying? It should be less than equal to 8. 8 tak chalega. Okay? So these are the conditions that you get. Now keep watching. These are all initial things. Now I really don't know where, how, what level you guys are. First separate. Do you see that these three all have the same pattern? That is different. So these three have the same pattern. So here you need to meet all of them. So what is the strictest condition? What did I say? All should be satisfied. So 10 karoge, this is satisfied, but this is not. So then you'll have to meet this also. So what is the strictest condition here? Less than 5. What is this? This is alone. This alone tells more than this. So what do you get finally? All values from -3 to 5. And if Sankalp, 8 values, if you're counting this, another very important, as important that I'm going to a new page and explaining it to you students. Many times you will have to count integers from A to B. Always try to keep the left hand side the smaller value and right hand side the larger value. So that you always frame your mind as from smaller to larger you're going, right, along the number line. And you have to count integers. And the answer is going to be larger minus smaller plus 1. And this includes both A and B. So this counting is going to be happening countless times, numerous times you are going to do it. And we cannot, last time I told you something that will happen many times. A plus B is known to you. A minus B is known to you. You have to find the value of A and B. Okay, and you have to be super fast here. We cannot always go back to a margin and explain this. Same thing, I cannot go back always and explain this. Yeah. And remember, it includes both. These all things I'm highlighting what is that, right? So what if I don't want both? Then subtract 2, remove A, remove B. First come to an answer that includes both. You don't want both, so subtract a 2, but this is what is going to be used most often. Okay, and you do not have to worry about positive negatives. If they are positive to positive, 5 to 18. How many values are there? 5 to 18. खटाक से बोलना चाहिए. 18 minus 5, 13 plus 1, 14. 14 is the answer. Okay, the interesting bit is, even if it is from negative to positive, you don't have to worry. 18 minus of minus 5 is a 23 plus 1, 24. And does it have that 0 in between? Yes, it has everything. You don't have to do any adjustments or anything, right? So I hope this is fine. So let's go back to our this. So we had to count here. So there are going to be 9 values. So a question which stumps quite a few people, but it is not going to be this. How have you taken A is greater than equal to 5 for the equation this? Karuna, take a value, na Saurabh. Take 6 value and tell me what happens. अरे करो तुम, देखो इतना पेंसिल वर्क मत करो. मैं बताया नेगेटिव है. अच्छा 100 ले लोगे क्या? बोलो 100 ले लोगे क्या?
Question में he mentioned that A जो है वो एक integer.
Okay, excellent. So therefore I said, Saurabh, you should ask your thing, right? You should ask correctly. So you are saying algebraically it becomes 17 by 3. Perfect. Perfect. So A is going to be less than equal to 5.6666. Now go ahead and tell me, can your A be a 5.666 or let's say 5.5? चलो तो A को आपने 5.5 डाल दिया. ठीक है, A को जब आपने 5.5 डाल दिया, the factorized form becomes this. Now tell me, is this a natural number? So comfortable? So what I'm trying to tell you is, some things that we have as a natural number means we were looking at negative should not be their index. Now we also know the index cannot be decimal numbers. Therefore I did not. Is all good? Yeah. Otherwise you are perfectly right. It will go till this, but then again I also know that these all cannot be decimal values. By the way, what do you do with the decimal values? Just since we asked, tell me, okay, I understood that 3 raised to minus 4 is going to become 1 by 3 raised to 4. But what is this decimal value going to be? Why is this not a natural number?
Root में answer है.
Perfect, yeah. So बाकी के क्या कर रहे हैं? ये this is nothing but 3 raised to 17 by 2. And this divide by 2 is nothing but square root. So it is no longer going to remain a natural number, right? Okay. So good enough discussion, a simple straight thing question, but sometimes catches my problem. Now, what is a factorized form of even or odd numbers? Now, students, while the textbook form is this, okay, now it is quite clear that many people are going to not like this form. A much easier form is 2 raised to A, 3 raised to B, 5 raised to C, and so on. Let me write one more, just to tell you that this is like only primes. Use this form to think. We are not mathematicians. Now, we are not writing a textbook. We are just doing to clear an exam. So use this form. It is much easier than writing P1, P2, P3. Now, could you tell me when is the condition that this is going to be an even before I start that? But you might also say, sir, this is not a factorized form. We found that this was 2 raised to 8, 2 raised to 4 into 9 into 5. Where is there a 7, 11? Where is there? There's no 7 and 11. Now then why are you saying there's a 7 and 11 here? There is, I can write that. What I can write is 7 is not present. 11 is not present. 13 is not present. So remember the index here can be 0 always. Right? Last time also we allowed 0. We said greater than equal to 0. It can become 0. Yeah. In fact, that tells me what is the factorized form of 1. 1. And why is 1 highlighted? Why I'm highlighting 1 is, you know, primes are unbreakable. Atoms, I said, not 2, 3, 5. You cannot break them. How are you going to form a 1 with a prime? Ye 2 le liya. So you cannot reduce it. You cannot break it. 3 also you can't. 4 also you can't. So in fact, what is it? It is nothing but 2 raised to 0, 3. None of the primes. Yeah, none of the primes are there. So I hope you realize. So because this will keep coming back again when all the indices are 0. Right? Very nice. So coming back to our question, this is a very simple question. I don't think so. You need my help. When will you say this number is even? For this number n to be even, n is even. Go ahead and give me a condition when the only condition is a is greater than 0. And we understand A, B, C, D are all whole numbers. Yeah. Are all belongs to set of whole numbers. Whole numbers kyu 0 allowed. Decimals are not allowed. That's it, right? So far so good. Now that equal to hat gaya, or if you want, put in 1 or more. And you should again be smart enough to understand that both of this is the same for whole numbers. If decimals are not allowed, they too are same. What is a value greater than 0? 0.5, 0.6, 0.7 are not allowed. So more than 0 is only 1, 2, 3, 4, right? Which is same as that. So you could, either ways in your mind, you could think. And when will you say that n is an odd number? When will you say that n is an odd number? The only way n is an odd number is when a is equal to 0. So if you notice, for even and odd, these are not relevant. These are irrelevant. The even and odd only depends upon the prime 2. Is it present? Is it absent? Simple, straight. And we'll see conditions in a moment. When is a number a square or a cube? So 720. Okay, 720. Okay, so let's see what do we get with this. So if I take 400. So again, take help of this 100. 4 into 100. 100 is nothing but 4 into 25. The factorized form is 2 raised to 4 5 square. Okay, if I take 144. 144, you know, is 12 square. These are different ways you factorize it. This is 2 square, 2 raised to 4. Oh, again, a similar looking form. But if I take 100 and let's say 80. Okay, so that is there's a 9, there's a 2, and there's a 10. Right? So tell me this is 2 and a 2 here, and a 3 square, and a 5. So this is a square, this is a square, this is not a square. So what is the difference? Again, a very simple thing. Even powers of prime. Perfect. Square ka think about what is a square. If there is a prime 2, there should be another prime 2 also. If there is a prime 5, okay, it is just alone 5. No, I want it squared, so that should be another 5 also. So anything should be present as packets. This is one way to look. Second way to look is it's a square when you can find the square root. So tell me what is the square root of this. So let's go reverse. And what is the way of square root? The square root is, so these all forms are going to help you somewhere or the other. Square root is this half. And when can you do this? This becomes 2 and 5. Okay, that is your 4 5s are 20. 20 ka square. Okay, if I try to square root this number, where is the problem? Focus on that problem area. So if I take the square root, if I take half, I get a 2 raised to 1, I get a 3 raised to 1, but this is the problem. This is the problem, this one. So that was a single, right? So again, to cut a long story short, student, just to save you all the time, yeah, so that we can focus on better things. I don't want to extend it. Yes, suddenly classes are going a little more than what I would like it. So again, to keep it short and sweet, this is a square only when each of A, B, C, D are multiples of 2. Okay, is a cube when it is when these numbers are multiples of 3. Cube root means 1/3. So you should be able to do cube root of it. So you should be able to divide the indices by 3. Okay, they should be multiple. When is it a perfect fifth power? Fifth power when all of A, B, C, D are multiples of 5, and so on. So now go ahead and tell me when is a number going to be a square and a cube? Both very common language, multiple of 2 and multiple of 3. So all indices A, B, C, D are multiples of 6. Go ahead now. So this was the first question that I put up. So tell me the smallest such number. Smallest such number, and when we say no, Priyanshi, just as a check, you are right, but then technically you are right. But then when we say multiples, listen students, it's understood that multiples means into 1, into 2, into 3. But you should always be cognizant of allowing a 0 over there. Because why allowing a 0? Because these numbers are in the index. No? And if the index is a 0, look, there's a difference between this number and this number. Here, if we call it a number, by number we mostly mean a natural number. So we cannot make it 0. But if A is in the index, can I make it a 0? Yes. Right? So remember, what are these? These all are in the index. So while they should be 6 or 12 or so on, take a 6 or 12 or so on, remember, but I should also allow a 0. So the first one is 2 raised to 0, everything raised to 0, 1. Next one, 2 raised to 6, 64. Now for those who are not cognizant, remember and memorize it. 64 is 2 8 square and 4 cube. How do I write it? Okay. Yeah, I'll write it this one. 8 square, 4 cube. Any next number? Next number. So, do you do 2 raised to 12? You could go. But tell me, okay, 2 raised, so not many people are coming up with numbers. Okay, I want the next number, and you need to know 3, 4 of them. Then you would say, now I'm prepared for the 99.9 percentile. You can't say, I did not know which are square and cubes also. Or you are sitting over there and finding them. Bilkul nahi. Very good. Now there are 2 things to do. Again, this will also help you students in your mind. You could go as single power to, okay, so listen. You could go to 2 raised to 0, 2 raised to 6, 2 raised to 12, 2 raised to 24, okay? Or you could go 3 raised to 0, 3 raised to 6, 3 raised to 12, 3 raised to 18. I don't know why I missed 18. Okay, and so on. It could also be 5 raised to 0, 5 raised to 6, and so on, and continue. Okay, so you could go to 12 and 7 also. but those numbers are going to balloon very fast. And you can also have combinations of them. Don't forget that you can have combinations of them. So I hope you realize, right? So very good. So students, and now when you take a combination like this, combination of all of this is that 1. 2 raised to 6 alone is this. 3 raised to 6 alone. Tell me the value of 3 raised to 6. You should know it, student. Anyways, why am I wasting time here, right? 729 is a perfect square and a cube. Okay, so it's a square of 27 and a cube of 9. You have to know this. Okay, now you could go to 2 raised to 12. 2 raised to 12 is going to be 4096. Okay, but then you could even do something else like a combination. Okay, so 2 raised to 12 is 4096. And how do you know a square? Just take a square root of it. 2 raised to 6. 2 raised to 6 is 64. Take a cube root of this. 2 raised to 4. Cube root karoge the 12 divided by 3, 4 aega na. 2 raised to 4 is what? 16. So 16 cube is 4096. You should be able to manage that, students. Yeah, it's not a very difficult thing. And I'm just thinking of a combination, right? So this combination, when you multiply, this will also become a number like that. So you need to know these numbers. You need to know. Anyways, chalo, I hope that's all. So let's see. When you do not know what to do, factorize. With what least number should 720 be multiplied to result in a cube? I do not understand what has to be done. Don't do, just factorize the number. 720 and I'm giving it directly. And this is student 720, 360, 144, 288, 1024. These are numbers which are so common that you should directly be writing the factorized form. 72 is 8 into 9 or 10 में 2 है. So 2 raised to 4, 9 and a 5. Now tell me, with what least number should this be multiplied? Look at the format how you do. You need to multiply it so that it results in a cube. Okay, and this is the least. So Bolo, you want this to be a cube. Is this a cube now? Where is the problem? What is the problem? Think. So should not be an issue. So the form is important. Once you get the form, then you should be able to complete it on your own. So 2 raised to 4, I want a cube. So this should be a multiple of 6. So what should I have? And I want least. I don't want a very large number. So this should become a 6. So what will you do? You'll multiply it with a 2 square. Is this a cube good enough? No. To cube, I need at least a multiple of 3. 3 का multiple. यहाँ भी 3 का multiple चाहिए था. हाँ, वो 3 you cannot reduce it. You have to increase it. Why? Because you're multiplying. So remember, when you multiply a number, you can only increase these. Okay, increase these, increase this, make them multiple of 3. So I guess if students, so if, okay, so let me write this only. I don't need that. If anyone is not clear, okay, everyone, students, anyone who is not clear, and anything, anyone, stop me and ask me then. Don't worry about anything. Okay, chat, maybe I might not look at every moment. I try to, but then standing on the board, there's a lot of things to worry about, right? So now you will have everything. This is a cube. So this is that least number. I hope you also appreciate the meaning of least. For example, you could have even multiplied it by 5. 2 raised to 4 will become 2 raised to 9. 9 is a multiple of 3. Like 2 raised to 5 is a big number. So that is the idea. So what is, again, now this is 25,400. So 300 as Naman has written, Sahiti, Sankalp, everyone. So look at the format. Students, you're not going to get such easy questions. Okay, this is just very simple manipulations that you should be able to manage. You should be able to understand the language. With what least number should this be divided? Remember that time you were multiplying. Now first check the factorized form. I keep repeating, you will make errors by being, when they give this way now, you should always be suspicious. They're not so nice people who will break it and give it to you. Something they must be doing the thing. So do make sure you check. And this time, since you are dividing it by something, you will reduce this. And you will reduce it again to result in a cube, it says. So 12 will work. Yes, 12 will work for a cube. So what do you reduce it by? Just 1. And look here, yeah, आ गया ना problem. मैं तो बोल ही रहा था और वो मिस हो गया. ठीक है, very good, Saurabh. Very good, Karthik, everyone, right? So this is a 9, so you will do 99 and 99 is the answer. ताली बजाओ. नहीं समझा. संकल्प, अमाय, नमन, प्रियांशी, अंश, साहित्य, सौरभ, कार्तिकेय, नाम डूबो क्या होगे? क्या? हाँ.
प्राइम नंबर में फैक्टराइज करना पहले इसको.
अच्छा, शायद यही हो आंसर, पता नहीं. I should also not jump the number. I should also not jump the gun. But if you did it this way, then you are messed. I was saying, they will not factorize it and give it to you as if it's everything is there. You would have to factorize it. Let's hope the answer changes. Let's see, because I jumped the gun. So this is 11 raised to 13, and this is 3 raised to 20. Oh, thankfully you got saved. If at all you did think of all this. Okay, I should have been a little smarter in giving this time. So this would be 11. So the final form is what? You need something less than this. This is 12. This is 3 raised to, what is less than 20? 19 or 18. I will use 18. Okay, chalo, okay. So I'll give you the benefit of doubt. Yeah, okay. So I'll take back my word. I hope you must have done it. Okay, chalo. Okay. Ending with zeros. A very simple question. Or rather, even simpler than this. No, will not waste time. How, think about it, ending with zeros. When will numbers end with zeros? Think. What? So find the number of trailing zeros. Now, those who don't know trailing zeros, pay attention to this, then I'll give you time to think. If I have a number like 1024, okay, and then 3 zeros. So the trailing zeros are these. Yeah, these are the trailing zeros at the end. In short, sometimes we just write the zeros at the end also, right? This is not counted. This one will not be counted because it is not at the end, right? So you don't worry about what is there here. You just worry about at the end. So any good idea here? LCM hoga kya, Saurabh? Socho LCM hoga. Okay, by the way, at least Saurabh has helped ki. This zeros at the end now. So for example, this number that I also took, when I first factorize it, what I'll do is I'll keep this separate and I'll say this is 1024 into 10 cube. So do you see that end zeros relate to 10? But please mind that 10 is not a prime number. So you are going to break it into 2s and 5s. So this ending of this, it relates to 2s and 5s. So the prime 2 and 5 you need to focus. So pay attention to this. So you have this 2 raised to 7. You would ignore this. You have this 5 raised to 6. You will ignore this. Will you ignore this altogether? Will you ignore that altogether? No, there's a 2 hidden over there. So you will take a 2 raised to 6 over there and the 7 part you will ignore. And remember, this is also 5 raised to 6. So you'll break all of them. I don't think so. This is very, very tough or so on. Don't forget to collect the like primes. Okay. And 5 raised to 12. Now, Saurabh, go ahead and tell me how many zeros, the number of trailing zeros, because I'm pretty sure you can tell me the answer. And later we'll write the very good. So how many zeros? 12. So will you say it is the LCM of indices? Let's say it is 2 raised. So what do we do? 2 raised to A, 3 raised to B, 5 raised to C, 7 raised to D, tell me, what do? You first focus only on A and C. And what is the answer? Who is going to, with numbers, it's easy. Who is going to give me words between A and C? The number of trailing zeros. The number of trailing zeros is, because if you can get that mathematical language, then it's pretty good. Very good, sir. It is the minimum of A and C. It is a minimum of A and C. Perfect, right? So 2s and 5s, you noticed it and so on. Now this can be made into a little more trickier things, right? And the trickier is, when will a number have exactly k zeros? So pay attention. So could you say again now? So let me give you a value for say. So if I say k is equal to 5, a number has 5 trailing zeros. So tell me, does the number necessarily have to have 2 raised to 5? Think and answer. Yeah, it's a nice thought. If you learn the final thing, you might miss out things. So is this necessarily going to be 5 only? Yeah. So okay, so no, not necessary. So I hope you all are emphasizing on not necessary. Okay, so give me something, then what can it be if not 5? I think it has to be 5. It should be 5. Okay, good. It could be at least 5, it has to be. Okay, it could be more than 5 also, individual. Okay, so now you have to think in your mind, yeah, how are others saying that 6 is chalega? 6, how will 6 work when I have 5 zeros? Hang on. Let me ask that individual question to 5. Now forget this, what we discussed. What can the power of 5 be? The power of 5 also, at least 5. It could be greater than equal to 5. Now I'm trying to build a logical reasoning thing in your mind. Independently, they both can be greater than equal to 5. This also, but collectively, can I say that, oh, they could be greater than 5 and this also could be greater than 5? Why am I leaving? Because this is not of any consequence, right? Now, can I collectively say that they are both? So wait now, right? So hang on, right? So this is where I said it can get very tricky. So I'm not telling you, I'm just putting a seed into your mind that, remember I told you there are some common factors and then we are going to slip over there. Same thing will happen over there. Individually, this condition had to be met. Individually, this has to be met. But collectively, when I look at the whole picture, I don't want both can happen. Both cannot be more than 5. Why both cannot be more than 5? Can you tell me one word because of which it is an issue? Because of this exactly. Okay, so I'm hinting and I'm telling you some nice thoughts, students. A much simpler way is, you say there has to be at least 5 zeros. Now, what has I changed the word to? At least. So could I say that A could be greater than 5, C could be greater than 5? Now, can both of the work? Yes. Could I say that there can be, if I want something like at least 6 zeros, could I say that A could be greater than 6 and C should be greater than 6? And the logical reasoning says the second situation minus the first situation, okay, will give you exactly 5 zeros. Which situations does this have? This has at least 5 zeros. So what is at least? 5 or 6 or 7 or 8 and so on. What is at least 6 zeros? You'll start with 6. Minimum 6. 6 and then go rightward. 6 or 7 or 8 or so on. Are all these a part of it? So when you subtract, oh, I should do 1 minus 2. When I do 1 minus 2, then I'll be removing off these cases, minus. In your minds, I have just given a seed. So when a question comes, you have to try it. As I said, this is not an application level class. This is your basic level class of where 2s and 5s are there. So we learned with zeros, rest will learn it in tougher things. Okay, last 2 bits quickly. So when is this number? If I say this number has to be a multiple of, let's say, 144. So 144 is nothing. Oh, okay, not the 144. Let me put it as, let's say, what, 190. What is an easy number? Why aren't numbers coming to my mind? Okay, 288. 288 is 2 raised to 5. 144 is 2 raised to 4. 16 into 9. Okay, 3 square. So now tell me, this number has to be a multiple of 288. We have almost done this, students. Yeah, last time I had written it differently. So this time I'm just saying this number is a multiple. So 2 raised to 5 into 3 square, and it could be anything else, any number. So if, and this, right? So could you tell me that what should A be? Perfect. Here A has to be greater than equal to 5. Because the 5, and you could multiply. If you multiply with 2 raised to 0, you'll get 5. If you multiply with 2 raised to 1, you'll get this. Okay. What should B be? B has to be greater than equal to 2. And what about the C and all? They all can be greater than 0 and so on. They can even be 0, doesn't matter. But it has. Can it just be 2 raised to 5, 3 raised to 2? Yes. You're multiplying it by 1. A multiple of 1 is also multiple. So what are we saying? Multiples may tell me what is this? A has to be 5 or more. B has to be 3 or more. So more has no limits. Keep paying attention. There is no limits. No limit, no upper limit. So link it with your mind. Does multiples, can there be infinite? How many multiples of 3? 3, 6, 9, 12, 300, 303, 300, 3000. They can keep going on. No upper limit. But now we come to the second part. Factorize for numbers that are factors. So what if I want a factor of 2 raised to 8 into 3 raised to 4? So I want a number n, which is 2 raised to A, 3 raised to B, 5 raised to C, 7 raised to D. This number is a factor of. Go ahead. You should come to the theory on your own. अपने आप हो जाना चाहिए. Yeah, you should not be thinking and so on to me. It's like a very easy thing. So this has to be a factor, not a multiple. Or the other way is, think of it. The other way is this number is a multiple of this. So did you get that idea, everyone? Okay, another way to think is, it is a factor means it will divide this completely. So tell me what power here will get divided, means the denominator should become 1. The denominator should get cancelled. And where did all these come from? These come from the simple thing. Tell me 24 is 4 a factor of 24? Is 4 a factor? Oh, the 4 can gets completely cancelled. 24 is a multiple. So that multiple and factor should go together, right? Is 5 a factor of 24? No, it's not. Why? Because the 5 doesn't get cancelled out. Yeah, this is not a multiple. That same idea. So So students, what can it be? It cannot be more than 8. It has to be less than 8. Okay, and similarly 3 has to be less than 4. And when it is less than, so remember greater than we mean right words. So let's say 8. So if I say greater than, we go that, it goes till infinite. Less than, can I go till minus infinite? Can I keep going on? When we say number, remember we had a condition that a can only go till 0. So what you should write down is, it could be only from 0 to 8. And this could be 0 to 4. Are we together, everyone? Now tell me how many possibilities. So this is the form. You got the idea, the factorized form. But the question now is how many number of factors? How many number of factors? So the factors of, first factorize it. So I'm not writing it again just to save a little time. Factorize it. Yeah, factors of this is of the form 2 raised to 0 to A, 3 raised to 0 to B, 5 raised to 0 to C. And tell me how many 0 to A are how many different values? They are A plus 1. Do you remember this also? I took another slide and said A minus 0 plus 1. Think about it now. 1, 2, 3, 4. These are counting numbers till A. A are there and a 0 and a 0. So these are A different values. And this 1 also. So how much does it become? A plus 1. So remember, sometimes we think where does this plus 1 come from? This came in for because of the 0. How many values are these? These are B plus 1. How many values are these? These are C plus 1. And we need a combination of them. Linkages with P and C, but not a lot of. Yeah, anything can combine with anything. So we multiply. Why do we multiply them? Look at this. 2 raised to 1 can combine with any of them. 2 raised to 2 can combine with any of them, like this. Okay, so if there are 1, 2, 3, 4, 5 branches, 1, 2, 3, 4, 5 branches. So how many happen? 5 twos are 10 branches in all. 5 values for this, 2 values for this, 5 into 2, 10. So those all are letters, right? That is what we are doing, Saurabh. This part when we multiply is the PNC, and there's no other way. You might break it down like what I am teaching and make it like a kg stuff, but then basically behind it is PNC logic. There's no other logic. And hence I verbalize those things so that you can even use it in any situation. N values for this, M values for this. Now I want to combine them. Combine them has some interpretation. So when you combine them, you do all this, right? So some solved examples, students. We still have one slide more to go for number of common factors. So let me finish this. Find the number of factors of this that are any natural number. It could be anything. So the power could go from 0 to 8. So this could be 0 to 8, say 0 to 7. So the answer you would write it as just 8. 3 could go anything from 0 to 8. And they are 9 different values. And 5 powers can go 0 to 4, which are 5 different values. So how do you multiply? Multiply the even 40, 360. You can be a step ahead of me also. These are easy questions. I'll just take a pause of just 10. I'll just count till 10 so that if someone has a doubt, you can ask. 8, 9, 5. A plus 1, B plus 1, C plus 1. When there is no condition. Now there's a condition. It has to be even. If it has to be even, this is the answer. Now there's no simpler way to multiply. So I'll multiply this 63. 6 is 300 and 15, if I'm not wrong. What has happened if it is even? Since it has to be even, the power of 2 will go from 1 to 7. And the others are same. Right? Odd numbers. What was the condition for odd? The power of 2 has to be only 0. And you don't take 0. You say 0 is one value. So what are these? These are the number of possibilities. These are not the numbers. So it's not saying 2 raised to 8. It is saying there are 8 different possibilities. Possibilities. And that is what we are counting. Find the number of factors. How many? ठीक है ना some students? Yeah. So I'm just hastening it up just to save that time. But it should all be okay. Which are perfect square? Now listen, students here. A beginner will do it this way, and I'm okay with it. Till the time you say कि I want to build speed. Perfect square चाहिए तो मतलब क्या है? The index will be multiple of 2. You could say even, but I would still say multiple of 2. So, but a 0 will be allowed. Remember, I told you that time index में 0 is allowed because that will become 1. Or a 2, or a 4, or a 6. Can it be 8? No. You do this like a beginner, it's okay. But then you want to save time, you have to reduce this one. 5 is going to be what? 0, 2, 4. So how many? 1, 2, 3, 4, 5 possibilities. 4 possibilities. Now why am I making this? 1, 2, 3, 4, 5 possibilities. 1, 2, 3. So, so the problem happens, students, is, for those who get scared of maths, especially those who did not have great teachers or so on, they haven't highlighted how we go from here to number of possibilities. Okay, and why are we counting and so on, right? Anyways, I don't want to spend time there. How can you do this faster on your own? Students, you can. You can. So take 8. 8 को divide by 2, 4. And 1 0 also. So that is 5. Take 4. 4 को divide by 2. There's 2. 2 1s are 2. 2 2s are 4. So you got 2 values and a 0. This is not divisible. Don't go 8. Now come to down. 6. 6 divided by 2, 3. 3 and 1, 0, 4 possibilities. Those 6 are 6, 4, 2, and so on, right? Okay. How many cubes? Multiples of 3. Let's try the same idea. This time let's do over there. Is this a multiple of 3? No. So what is a multiple of 3? Before it, 6. 6 divided by 3. 2. 2 and 1, 3 values. Is this a multiple of 3? No. 8 is not. So come lower than that. You can't go to the higher one. 6. 6 by 3. 2. Add a 0 to it. 3. 4. Multiple of 3. 3. Divide by 3. 1. 1 and 1, 2. Which are those? Pay attention. 0, 3, 6. I'm just looking here. 0, 3, 6. 5 raised to 0, 3. Could this have been 9? No. Could this have been anything higher? No. So I want multiples of this. We have seen this. If I want a multiple of this number, then this can be only more than 2. 2 to 7. Okay. It should be more than 3. 3 or more than 3. 3 to 8. Why is there a limit? It has to be a factor. This gives me the upper limit. This gives me the lower limit. Right? This has to be 5 raised to 1 to 4. And now count. Okay. Now look here, student, how I'll count. Same thing. 2 to 7 minus 2, 5 plus 1, 6. 8 minus 3. 5 plus 1, 6. 4 minus 1, 3 plus 1, 4. Do you see in the same class how many times that counting has happened? So this is your answer that, and have at least 3 days. This has saved my day. So when you come back, I want you to answer this one having exactly 3 ko kya karoge. This is easy, so I'm finishing it off. 3 trailing zeros, this has to be minimum 3. It could be more also, 3 to 7. 3 has no conditions. Quick, anyone has any doubts over here? Now is the time to ask. You need 3 trailing zeros, 5. You at least need 3, 5, 5, 5. 3 to upper limit 4. How many values? 7 minus 4, 5 values. This is 9, and this is 2 values. Okay, Saurabh, I have a doubt in at least 5 number or trailing zero. करो ना Saurabh, इसका answer exactly करके दो. चलो सब जन अभी नहीं करना है. We are going to take a break right away. Okay, exactly करके दो. Exactly 3. Copy this number. 273854. Find for exactly 3 zeros, and that's the reason why we take a break, so that you can do this. So let me finish this common factor, students. Yeah, that's all. Common factors. Now, for the easier student again, yeah. So if I want a common factor to both of these, so this is number 1, number 2. Don't, again, a very nice classical way, a very classic way to think. Don't look at the full number. When I explain, I'm explaining bits and pieces. That is how you learn. So if I say I want a common number factor to both of them. So tell me, if I want a common factor, what can be the powers of this or so on? Can it be 2 raised to 6? Think and tell. 2 raised to 6 will divide this, but it won't divide this. So what will we take? We will take the smaller of the number. So it could go anywhere from 0 to 5. Okay, so now you know. So this is 3 raised to 2 and 3 raised to 4. This time you wanted common factor. Now you will need a number which divides this also, this also. This is bigger number. There'll be more things that will divide, but I want both. So you will take that lower one. So do you see what's happening? Once you took this lower one, once you took that, whichever is the lower you will take. Now let's say this has a 5 cube, okay, and this has a 7 cube. Now I'm helping you out by writing it this way. They will not write. So tell me which is the lower of the two. You can't have a 5 raised to 1. It will divide that, but it won't divide this. So think there's a 5 raised to 0, and the lower of 0 and 3 is 0. And this will also be this, so nothing else, right? So this is the number of common factors. How many number of common factors? This will be 6 values. Again, write what is that 6? 6 are the possible values. 3 possible values, combinations, branching out. 6 into 3, 18. Okay, so finish this question and go. Finish this question on your own. Give me an answer quickly and then go. How many factors that are common to both the numbers? Oh, this is pretty easy. 25. Good, Muskan, Sankalp, everyone. And Joby, whatever you have done now, always push yourself. If you found it very easy, then say, could I do it easier, orally? So look, my thought, I would still want to put in something of a value. So listen, I would look at these two and I would say 4 is that. So 0 to 4 is 5. Listen, stop. 5. My answer is a multiple of 5. So I look at options, which is a multiple of 5. If there's one multiple, that's my answer. That will save me doing anything further. Nah? Yes, something comes into play if at all you are going that 99.999 thing. Every moment stop, think, alert kind of. Chalo, good. So I'll put up questions over there. Some nice questions are there. Then we'll come back and do some extra bit. And right. I hope today's class was okay. Ansh, it was better off today. A little more standard stuff. Not only Ansh, it's Ansh because I like to talk to people. Yeah, Ansh asked me something, so I'm asking him. Others also, please let me know. This is a standard question. You want tougher things? Come in the next class. Yeah, we'll do a little tougher. Done? ठीक है ना आज का okay था? हाँ. Good. It's not just audio, Ansh. Yeah, others, anyone who has work. So let me know. Fine tune it. Don't just go गायब मत हो जाओ. यार कैट तुम्हारा रह जाएगा अगर गायब नहीं होगे. पैसे दिए हैं यार, पूरा सीख के लेना है जो भी करना है. ठीक है, चलिए जाइए, मैं क्वेश्चंस डाल रहा हूँ, ट्राई कीजिए. 9:40 को मिलेंगे. बाय बाय.